Key technologies were the development of a communications network, which is what I got my doctorate for at McGill. Positioning and navigation systems, which some of the students I've had have worked on both at McGill, Queen's, and Laurentian. We've sorted out how to do some pretty fancy things with positioning systems. Software systems were pretty straightforward for us, but mining methods and the methods of using this technology became quite important. And obviously, when you're in a business, dollar signs become more important. But we had to fit across the mining equipment and the process systems that allowed you to run a mine. A mine is like an entire city. You have to understand that there is usually about 500 people working underground at any given day. And in that, you have to provide them with potable water, with air, with everything that's needed, power, and all those things have to come together in unison because otherwise they can't work there. And today we're starting to approach depths where I've seen, for example, a 6-inch diameter hole in solid granite flow shut like molasses in a 24-hour period. So the ground pressures are becoming so large that you have to get the people out of there. And that's what we've been working on. So the very first invention we had was very simple. It took broadband cable television, and we linked a special device to it, which was called a DAT. That DAT allowed you to have 500 megabits per second available underground anywhere. Because we have this big advantage underground. The minute you go 20 feet below surface, the CRTC and all those people have no idea, don't care, and you can have the whole radio frequency spectrum to yourself. And you can duplicate it again in every single mine, and everybody who's in the aerospace business gets so upset when I say that, because they just like to have like a fraction of what I was able to use. This was a little video we had of the comm system. It's very simple. It's broadband cable technology to a box, and the box had antennas that went out of it that were called leaky feeders. That leaky feeder system was nothing more than a cable with the shield cut off it so the radio waves could leak out. Very, very simple. Very straightforward. But what it allowed us to do was run a number of pieces of equipment. Before I go to the piece of equipment we ran, the other most important piece, and you have to think about it this way, when I went to Japan and I was standing on the Nissan assembly line, you have all these robots all working around, creating the robot welds and doing all their business. The one thing that most people didn't see was that all those robots were planted in the floor at precise locations. Everybody knew exactly where every robot was because every robot was going to make a specific motion to make sure that weld was within a tolerance that kept you in a spot. Well, really, really difficult to do when the robot has to have wheels under it. Because to get survey quality accuracy when you have a wheeled device is very hard. So we started doing a lot of work, and I got involved a little bit with the US military, which was kind of fun. Draper Labs out of MIT, which is also kind of fun place. You want to be careful how deeply you get into that, but it's kind of fun. And we started working on this device, which was actually a Honeywell device for guys who had a very bad Star Trek rerun problem. They called it the Honeywell Ore Retrieval and Tunneling Aid after an episode of Star Trek where there was this silicon life form that would eat rock and poop out the good stuff. And so they called it that. Really what it is, it's a device that allows you to use ring laser gyros to very accurately position. And it turns out you can't use GPS underground, and so you had to find a way to do it with gyros. So that Horta, what happened there? There we go. That Horta linked with really inexpensive scanners. If you put them on board this type of machine, you can get the line and you can get the scanned areas to do 3D imaging. This is an image taken quite a while ago, but what it is 2 kilometer-long tunnel reconstructed using those laser scanners and the positioning unit. It turns out that since we've done this work, we're able to do this much more accurately now than we could do it then. We just closed a traverse in a piece of commercial work we did for a mining company where we did 30 miles of tunnel surveying, and we closed the traverse on 2.2 centimeters, which is a frighteningly good accuracy for those who understand that. You can hang up those Skype calls. These units now have evolved into these pair of robots, which are a patented device that we have put forward. What's interesting about these robots is that on board, wrong button. On board this unit, we needed to go in and be able to remove a barrier and do a survey. But we also had to provide telecommunications to this area because we were going 1.5 kilometers into a mine that was closed down because the top of the mine was failing, and nobody had been in the mine for almost 2 years, so all the ramps were washed out, and we had to traverse our way through this operation, through 4-foot ditches and all the rest of it, down into the mine just to do a laser scan for people so that they could see the quality of the mine. The quality of the rock, sorry. The main reason was there was a 100,000 liter propane tank sitting on top of the collapse zone, and if it went in, it would create a rather large bang. And so we had to build this robot system to make that happen. But Wi-Fi systems don't work for very far, so we had to build ourselves a communications tower, which is mobile, and then we had to be able to link that to the robot that was actually going to do the work. Oh, okay. And so we built those now, and now we're starting to commercially build them. We have orders for 5 more systems around the world. Chile, obviously, after the disaster with the Chilean miners, want to be prepared for the next anything that could possibly happen, and a few other organizations. So I want to go backwards now in time and show you a little bit about teleoperation. This was those machines that were just in the previous part of the slide. This is now one of the guys that work for me at Inco, and he's running simultaneously 2 machines between 2 different mines. He sits on surface 24 kilometers away from Stobie Mine with all of the gauges and all the dials, and he runs that machine up to a point, and then he puts it in automatic guidance, and the machine takes off on its own. And while it's in automatic guidance, he flips back over to a completely different mine and runs the machines in that mine. Now, for those who know about situational awareness systems and all those things, being able to not only teleport somebody from one area in a mine to another, but to take them to a whole new mine means you need a bunch of map systems and all kinds of things for people to understand. And he was able to do all that. Caused huge problems in the organizational structure of our company. Because what we had done inadvertently was promoted him to being in supervision. He was a cog in the machine before, and he was part of the robot. But when he started running 2 and 3 and 4 machines, he was now the guy running the fleet, which is what our supervisors did. So we ended up with organizational compression at a level that was quite significant and caused the mining company to go into a bit of a tailspin. You know, it's one of these things, they're bonus miners, so this guy here made the most tons, so he should report to this general foreman, and this guy here, well, he worked at the higher grade mine, which had more nickel, so he made more nickel pounds, so he should report to that general foreman, and those 2 general foremen fought over who should be in control until we put this into a little contracting business.